Imagine standing at the very edge of the universe, staring into the infinite expanse of space, with a sense of awe and wonder. It is a place that humbles us, a vastness beyond comprehension, where the answers to the most fundamental questions of existence lie waiting to be discovered. For centuries, humanity has looked to the heavens to answer questions about the origin of everything, about our place in the cosmos and how everything we know came to be. The Big Bang Theory, which posits that the universe began as a single point and then expanded rapidly, has long been our guiding framework for understanding the birth and evolution of the universe. Yet, in recent years, a new era in astronomical research has emerged, driven by the unparalleled capabilities of the James Webb Space Telescope, JWST. With each groundbreaking discovery, scientists are now realizing that our view of the universe, and even the very fundamentals of how we perceive it, might need to be completely rewritten. The concept of the observable universe is central to our understanding of the cosmos. When we look out into space, we are not simply gazing at distant objects but rather looking back in time. Light, which travels at a finite speed, takes time to reach us. The farther we look, the further back in time we peer. The observable universe refers to that part of the universe from which light, or other forms of radiation, has had time to reach us since the Big Bang. The universe, which is thought to be 13.8 billion years old, contains regions that are so far away that their light has not yet had time to reach us. So, while we can observe a vast amount of space, we cannot see everything. There are limits to our perception. This is why the JWST's discoveries are so profound. Launched in December 2021, the JWST is the most powerful space telescope ever created, and its infrared capabilities allow us to peer deeper into the universe than ever before. For years, astronomers have been limited by the capabilities of previous telescopes, including the Hubble Space Telescope. While Hubble provided us with breathtaking images of distant galaxies and stars, its limited sensitivity to infrared light meant that it could not see the most distant and faint objects in the universe. The JWST, on the other hand, is designed to observe the universe in infrared wavelengths, allowing it to detect objects that are billions of light-years away, even those whose light has been stretched and dimmed by the expansion of space over time. One of the most fascinating aspects of the JWST's capabilities is its ability to observe the universe as it was in its earliest stages. The first few 100 million years after the Big Bang were a time of rapid and dramatic change. After the initial explosion that created space and time, the universe was incredibly hot and dense, filled with a hot, glowing plasma of hydrogen and helium. As the universe expanded and cooled, it eventually reached a point where atoms could form, and the first light was able to travel freely through space. This period, known as the recombination epoch, occurred about 370,000 years after the Big Bang, and it marks the point when the universe became transparent to radiation for the first time. However, this light was not visible to our eyes. It was in the form of cosmic microwave background radiation, which still permeates the universe today. The next key phase in the universe's evolution came much later, when the first stars and galaxies began to form. This period is known as the cosmic dawn, and it is thought to have occurred between 300 million and 1 billion years after the Big Bang. During this time, the universe was still largely filled with neutral hydrogen gas, but the formation of the first stars initiated a process known as reionization. These stars emitted ultraviolet light, which ionized the hydrogen gas, turning it from a neutral state into charged particles. This process gradually made the universe more transparent, allowing light to travel freely and illuminating the cosmos for the first time. It was during this period that the first galaxies began to form, setting the stage for the vast array of galaxies, stars, and planets that would follow. For decades, scientists had theorized about the cosmic dawn, but the exact details of how the first galaxies formed and how quickly they evolved remained largely a mystery. This is where the JWST has made its most surprising and groundbreaking contributions. The telescope has observed galaxies that existed at incredibly early times in the universe's history, much earlier than previously thought possible. One of the most extraordinary discoveries made by the JWST is the observation of a galaxy known as JWST 14. This galaxy existed just 290 million years after the Big Bang, making it the oldest galaxy ever observed. The fact that such a massive and luminous galaxy could have formed so soon after the Big Bang challenges many of our previous assumptions about how galaxies evolve. But what makes this discovery even more fascinating is the fact that the light from JWST 14 has traveled for over 13.5 billion years to reach us, allowing us to observe it as it appeared in the distant past. The JWST's ability to detect such faint and distant light is a testament to its incredible capabilities. The galaxy is unusually bright, which suggests that it has a mass hundreds of times greater than the Sun, a finding that raises important questions about the speed and mechanisms of galaxy formation in the early universe. According to previous models, galaxies should have taken much longer to form, and their growth should have been a gradual process over billions of years. But JWST 14, with its immense brightness, seems to contradict these assumptions. How could such a large and luminous galaxy have formed so quickly after the Big Bang? In addition to observing distant galaxies, the JWST has also provided new insights into the formation of stars and other cosmic structures. One of the most fascinating findings involves the discovery of protoglobular clusters in the cosmic James Webb galaxy, which existed just 460 million years after the Big Bang. Protoglobular clusters are dense regions of gas and dust where stars are born, and they are considered the precursors to the globular clusters we see in the universe today. These early star clusters provide scientists with valuable insights into the conditions and processes that led to the formation of stars in the early universe. By studying these clusters, astronomers hope to learn more about how the first stars formed and how matter was distributed in the early universe. The cosmic James Webb galaxy itself is an example of how the gravitational lensing effect can allow us to observe distant objects that would otherwise be invisible. Gravitational lensing occurs when the light from a distant object is bent and magnified by the gravity of a massive object, such as a galaxy cluster, lying between the observer and the object being observed. In the case of the cosmic James Webb galaxy, the light from the galaxy is magnified by a nearby galaxy cluster, making it possible to observe the galaxy in far greater detail than would otherwise be possible. Without this magnification, the galaxy would have been too faint for the JWST to detect, even with its advanced infrared capabilities. This phenomenon of gravitational lensing has been a game-changer in astronomy. It allows scientists to study distant galaxies and other cosmic structures in unprecedented detail, providing insights into the early universe that were once thought to be beyond our reach. The JWST's use of gravitational lensing to study the cosmic James Webb galaxy has given us a view into a time when the universe was just a few 100 million years old. This is an extraordinary achievement that pushes the limits of what we know about the origins of galaxies and stars. The discoveries made by the JWST have raised important questions about the nature of the universe itself. For example, if galaxies like JWST 14 could form so quickly after the Big Bang, does this mean that our previous understanding of galaxy formation is incorrect? Could there be new processes at play that we have not yet discovered? These questions are challenging long-held assumptions about the timeline of the universe and its evolution. The fact that such massive galaxies could exist so early in the universe's history suggests that the processes of galaxy formation and evolution were much more rapid than previously thought. This finding has led some scientists to reconsider their models of cosmic evolution and to explore new theories that could explain these unexpected observations. One of the most exciting implications of these discoveries is the possibility that the universe is much older than we thought. The existence of galaxies like JWST 14 implies that the universe might have been capable of forming large and complex structures much earlier than our current models suggest. This raises the tantalizing possibility that the universe could be much older than the 13.8 billion years we currently estimate. In fact, some scientists have even suggested that the universe could be infinite, with no beginning or end, a concept that challenges everything we thought we knew about the origins of the cosmos. As the JWST continues to make groundbreaking discoveries, it is clear that we are on the cusp of a new era in our understanding of the universe. The telescope's observations have already forced scientists to rethink their models of galaxy formation, star evolution, and the very nature of the universe itself. With each new discovery, we are uncovering more about the early history of the universe and the processes that shape the cosmos as we know it. It is an exciting time for astronomy, and the potential for further breakthroughs is enormous. At the same time, these discoveries also remind us of the vastness of the unknown. While the JWST has provided us with unprecedented views of the universe, there is still much we don't understand. How did the first galaxies form? What triggered the process of reionization? What is dark matter, and how does it influence the evolution of galaxies? These are questions that will continue to drive scientific research for years to come, as astronomers work to piece together the complex puzzle of the universe's origins and evolution. In the end, the revelations from the James Webb Space Telescope are not just about distant galaxies and stars, they are about our place in the cosmos and our ability to explore the deepest mysteries of existence. Each new discovery brings us one step closer to understanding the true nature of the universe and the incredible forces that have shaped it. With the JWST leading the way, the future of astronomy is brighter than ever, and the possibilities for new discoveries seem limitless.